so that if you ever want to go back and rewatch me go through the notes with you guys as a class again, you will be able to. Let's see, this one, this one, this one, this one. So let's go ahead and get everything pulled up here. All right, awesome. So before we get started with the notes for this evening, I just wanted to remind everybody that our first exam for this class, our midterm test, is going to be going up later on, well, not later on this week, tomorrow morning. So this midterm is a little bit bigger than some of the work that you've been doing in this class previously. That's why if you look, you can see that the midterm is not due until the end of the day on November 20th, which is Friday. It also says that right up here. So you have all day Wednesday, all day Thursday, and all day Friday to work on the midterm. It has a variety of different types of questions, from multiple choice, fill in the blank, true, false, short answer. And it's all based on everything that we've talked about in class so far. So there's some questions on solids, liquids, and gases, and heating curves. There's some questions about atoms and the electrons and protons and neutrons and electron shells. And there'll be some questions from some of the stuff that we're going over this week in terms of the mixtures and the compounds and stuff that we're going to be talking about. So as always, you can do the exam either in Google Doc form, where it's just one big version of the exam. So for the Google Doc, if you want to, for multiple choice questions like this first question, you can either write in the answer somewhere, or you can highlight the correct answer so that there's a highlighter button right up here on the Google Docs. You can highlight the correct answer. You can bold what you think the best answer is. Any way that you want to show to me what you think the answer is, you can use. And then, like I said, there'll be some fill in the blank questions. There'll be some short answer questions where you have to write in with your own words. And then there'll be some questions that might look a little bit similar, asking about different types of atoms. So that is what the Google Doc version of the midterm looks like. There's also the Google Forms version. I know a lot of you guys like using the Google Forms. It's a little bit easier to get through. So on the Google Forms version, it's all the same questions, all in the exact same order. But the Google Form version is broken up a little bit into sections. So the first section is just the introduction section. But then when you hit next, it'll be the next section that has all these different questions. Again, they're the exact same questions on the other version, just in the next section. So you go through, answer all of those. And then once you answer them all, you'll hit next to go on to the next section. So since you're doing this exam online over multiple days, you have access to the Google Classroom. So if you ever want to go back and look up old notes or old videos of me going through the notes to help you with the exam, then you're more than welcome to. Also, you can reach out to me if you're having trouble. Obviously, I can't directly help you get the answer to a specific question. But if you're confused about what a question is asking, or you're not quite sure what your answer is supposed to look like, those are the types of things that I'll be able to help you out with the midterm. So again, you won't see it quite yet. It doesn't go live until Wednesday morning, but tomorrow at 12:01 a.m., it'll be open for everybody to look at. But again, it is not due until Friday at the end of the day. So you have all day Wednesday, all day Thursday, and all day Friday to work on it. It's not super long. I think it's about 23 or 24 questions long. So it's not like a huge 700 question exam or anything like that. But it still is a lot more questions than have been on your assignments and stuff. And they ask for a little bit more detail than maybe some of your different worksheets and stuff. So I wanted to make sure to give you guys plenty of time to work on it over the course of the end of the week. All right, anybody have any questions about the midterm? Anything that I didn't go over that you're still not sure about?
I have a question.
Yeah, go for it.
Oh, sorry. If we do it in Google Docs, we can do like some tomorrow, some Thursday, some Friday. Like it doesn't have to start over, right? It'll save it.
Right, exactly. So yeah,
okay.
If you put in the Google Docs version, then it'll save whatever you type in there. If you do it in the Google Form version, then unfortunately it won't. If you have to exit out, it won't save your past answers. So either if you want to write down your answers as you go along and then turn it in all at once, or just keep the doc open on like a separate tab while you work on other stuff, that is all totally fine. But yeah, the Google Doc will automatically save your work for whatever you put in to it.
Okay, thank you.
Good question. Anybody else, any other questions relating to the midterm? All right, so make sure to keep your eyes on the Google Classroom tomorrow because that will be going up. So the final section of the midterm has to do with the stuff that we are going to be talking in class today, which is about mixtures and compounds and how we can take those atoms that we've been talking about previously. So up to now, we've kind of been looking in at the nitty-gritty of the atoms, right? We've been talking about the protons. We've been talking about the neutrons. We've been talking about the electrons and the shells that the electrons go on. Today, we're going to kind of zoom out a little bit and instead talk about how atoms can interact with other atoms. What are the different types of substances that we can create from these different atoms that we have? So at the beginning and at the end of the day today, we're going to be looking at this big matter flow chart, which kind of tells us how to break down all the different types of matter that we'll be talking about. Again, just as a refresher, matter is sort of the scientific word for stuff, things. Everything in the universe is matter. And so that's what we call it in science. And then we'll talk about kind of the two major divisions of matter that we can kind of split between, which are our pure substances and our mixtures. So up first, we have kind of everything that we are going to be talking about today. I know it looks like a lot all thrown up on this one slide, but I promise we'll talk about and kind of break down each one of these things piece by piece. So if we have our matter, our first question is going to be, can we separate that matter apart physically? So can we physically separate out different particles from each other? If we cannot, if everything in there is the same particle, the same kind of thing, then it's what's called a pure substance. But if we can separate out some of those different pieces and we can kind of group them into different types of particles, different types of atoms, then we might have what is called a mixture. And so we're going to break down what sorts of pure substances are there and what sorts of mixtures are there. And so by the end of the day, you should be able to know a little bit about what do each one of these different types of pure substance or mixture mean, kind of down here on this bottom row. So first up, we're going to be talking about our pure substances. So a pure substance is when we only have one type of particle present in our substance. So every single different particle that we look at, every single tiny atomic particle looks the same. So there are two different ways that we can make up a pure substance. We have elements, which is sort of a similar way to say atoms. So if you remember from last week, we were talking about the periodic table. So that big table with all of those little boxes all in it. The full name of that table is the periodic table of elements. And that's because atoms are sometimes also referred to as elements. So if we only have one single type of atom in our substance, then we have a pure substance that is made of only elements, only one single type of element. So like in this little picture, in this little diagram here, the only element that is present is this black dot, right? There's no other types of atoms that are in here. The only particles that are here are these black dots. So that is our elements, when there's only one single type of particle, type of atom, excuse me. We can also get a pure substance in a little bit different way, and that's through something called a compound. So we'll talk about compounds in a lot more detail in just a second. But essentially, compounds are when we have multiple different atoms that are fused together. They're stuck together. And so when they're fused together, we consider them as one compound. And so in this little diagram over here, we have three different examples of a kind of one black dot, two white dot compound, right? So each one of these particles is still the same, right? They're all two white dots fused to one black dot. So because it's the same particle, because it's the same compound, sorry, there's a phone ringing back in the background. But because it's the same compound, it's still a pure substance. So the only type of particle in this substance is this one single compound, which is what makes it a pure substance. So elements are when we have just the single atoms on their own, the single type of atom. Compounds is when we have different atoms that are fused together, that are kind of chemically stuck to each other. That's what gives us a compound. So because they're the easier type, we'll talk about our elements first. So an element is when matter is composed of identical atoms. So every single atom in this matter is the exact same type of atom. So like when vases are made out of copper, like pure 100% copper, like the ancient old-timey vases, this would be one single element in here. Every single metal atom in here is a copper atom. It's not mixed with anything else like lead or tin or silver or anything like that. It's all 100% pure copper. Same thing with gold over here. So gold is also a type of atom. It's one of the weird ones where the symbol for gold is AU. And so these gold bars right here are all made out of the exact same element. They're all made out of 100% pure gold. There's no other atoms that are mixed in or combined or hanging out in these gold bars. It's all 100% gold. So since it's all the exact same type of particle, it's all one type of particle, it is a pure substance. And since all of our particles are just single identical atoms, we can call it an element. So every single atom is the exact same. That's what gives us our element. So compounds are the little slightly bit trickier version. Compounds are when we have two or more different elements bonded together. So the key word here is different. And actually, you know what? I'm even going to go in and change this a little bit on here, just because it's so important. I don't know why I didn't do it this way before. There we go. Two or more different elements, different atoms bonded together. So they're stuck together. They're like glued together at the chemical level. So usually when we have a compound, it ends up with properties that are a little bit different than the individual atoms that started on their own. So, for example, table salt, the stuff that you put on your food to give it that extra little kick of flavor, is a compound. And table salt is made out of the atom sodium, which is Na, and the atom chlorine, which is Cl, bonded together, stuck together at the chemical level. So sodium chloride, or NaCl, gives us salt. So salt, obviously, very stable. You can leave it sitting out on the counter. You sprinkle it on your food to make it taste good. But sodium on its own, so pure sodium, is an extremely reactive metal that is potentially explosive when it comes into contact with air or water. And pure chlorine on its own is a very toxic and dangerous gas. So we have these two otherwise toxic chemicals or explosive chemicals, but when they bond together and make that compound, that NaCl compound, to make table salt, their properties change and they become very unreactive and, luckily for us, very delicious. So we take these two different elements, right, the Na sodium and the Cl chlorine, and we bond them together, and that's what creates our compounds. So if all the salt in here was all 100% pure salt, the only thing that was present were the NaCl atoms making up the salt, then we would have a pure substance in our little salt shaker right here. If Na and Cl are the only atoms that are present bonded together in this compound, then it is a pure substance. So some other compounds that you may be familiar with. Water, another very important compound that we use to drink and keep hydrated. You've probably heard of the chemical formula H2O before. So like water, H2O is the formula for it. But what that means is that a water particle is one oxygen and two hydrogens stuck together. So we have two different atoms that are fused together is what makes it a compound. Same thing with carbon dioxide, which is CO2. Again, two different atoms, carbon for the C and oxygen for the O. We have one carbon and two oxygen atoms that are stuck together, and that creates one carbon dioxide compound. Another famous one that is a big deal for most people is ethanol, which is two carbons, five hydrogens, and then an oxygen hydrogen group on the end. And ethanol is the alcohol that you drink in your alcoholic beverages. So when like a beer says that it's 4% alcohol, or if a wine says that it's 12% alcohol, that means 12% of the volume of that wine is made up of ethanol, C2H5OH. So we create this compound by chemically combining multiple different types of atoms together into one single particle, one single compound. So an element, a pure element, is when we have just one atom that's present. A compound is when we have two or more different atoms that are combined together, fused together, chemically bonded with each other. So if we only have one type of these substances present in our matter, then it is a pure substance. All right, so to go back to our little picture here, if we only have one single type of atom in our substance, then it is a pure element. Or if we have only one type of compound present, so there might be different atoms, right? If we had 100% pure water in a glass, we would have hydrogen and oxygen atoms floating around, but they would all be combined together as an H2O compound. So we could still say that that water is a 100% pure substance if these H2O compounds were the only chemical compounds present. No other chemicals are in that water. No other atoms or compounds are present. Just that one single type. All right. Any questions so far on elements, compounds, or pure substances?
No, Mr. Stanley, thank you.
No problem. Anybody else? Any questions on the elements, the compounds, how they combine together, anything like that?
I do have a question.
Yeah.
For what did you say on the pure sodium? Like pure chlorine is toxic and dangerous gas, but what did you say about the sodium?
Sodium is an extremely reactive metal.
Reactive. Okay. Metal. Okay.
Yeah.
Thank you.
So it will very violently react with other elements or compounds that it comes into contact with. So when it's 100% pure like that, then it's dangerous on its own. But when the sodium and the chlorine combine, they turn into a new and different compound, aka sodium chloride or salt, that has totally different properties than the dangerous stuff that it came from.
Okay, got it.
All right, so these pure substances are when we have only one type of particle present. Maybe that particle is a single atom. Maybe that particle is a bunch of different atoms all fused and combined together into a compound. But whatever the case might be, if there's only the one type, then it is a pure substance. On the flip side, we can also have matter that is made up of lots of different types of particles all combined together. And when that happens, we no longer have a pure substance. Instead, what we have is called a mixture. So a mixture is a combination of two or more different pure substances. So if you have lots of different particles all combined or all mixed together, then we have what's called a mixture. So, for example, in this mixture down here, we have a black element, we have a white element, because remember, in order for it to be a compound, there have to be two or more different atoms. For this white element right here, it's the same atom just bonded to itself. So this is still a pure substance right here. This double white atom is still a pure substance, or still an element, excuse me. So we have a black element and we have this double white element, but since it's the same atom bonded to itself, it's still an element. We also have this compound down here. So this one black, two white compound makes a reemergence. And all of them are together in this one substance. So that is what makes it a mixture. So there's not just one type of particle present. There's lots of different particles all around. So when we get all these different particles all together, we have a mixture on our hands. So if we do have a mixture, then there are kind of two different types of mixtures that a substance can fall into. The first one is called a homogeneous mixture, also sometimes called a solution. So the one big thing to remember about a homogeneous mixture is all of the different particles are equal and even. So there's the same amount of them and they're evenly distributed all throughout the mixture. In general, mixtures are only homogeneous when they have very small particles, because the very small ones are easier to make even and equal distributed throughout. So a lot of medicines that we take are homogeneous mixtures, right? So like these eye drops right here, every single time that you use these eye drops, you're expecting to get the same amount of medicine and the same amount of water. Hey, Anna, no worries. Thanks for being here. Whenever you put an eye drop in your eye, right, you're expecting it to be the exact same. So usually eye drops are a little bit of eye medicine mixed in with a whole bunch of kind of salty water called saline. And so from the first drop to the last drop of this eye drops, if I want my money's worth, I'm expecting each one to be completely evenly mixed, right? Every single eye drop should give me the exact same proportion of medicine and water, because all of the parts of this eye drop are equally and evenly distributed. You have the same amount of each type of particle all throughout the little eye drop bottle. So some other homogeneous mixtures include things like mouthwash, right? Every time that you use mouthwash, it should be the same combination of antiseptic and water and sometimes a little bit of alcohol to help kill the bacteria. And you're expecting that every time, right? You're hoping that whenever you take a sip, it doesn't just taste like pure like water that you're drinking, or you don't get like a super strong hit of the antiseptic all at once. You're expecting it to be evenly blended every single time that you use it. Same thing with vinegar. So vinegar that we use in our homes and for cooking and cleaning and stuff is a mixture of water and a particle called acetic acid. And so each capful of this vinegar, when you're adding it to your dish or to your cleaning solution, it should have the exact same combination of water and acid, right? It should be all completely evenly mixed together. Same thing with your coffee. If you use like the classic drip coffee, where you have the filter up top that catches all of the coffee grounds and you just have the liquid coffee coming down. Every single sip of this coffee should be the same, right? It should have the same mixture of water and caffeine and coffee flavoring, all mixed evenly throughout the coffee pot. So you shouldn't get a sip of coffee that is like really gross and super watery, and then the very next sip get like a super shot of really dark, bitter coffee, right? It should be all nice and equal and even. Same thing with peanut butter. So peanut butter is one of my personal favorite foods. I love peanut butter. And with creamy, so this only works for creamy peanut butter, but creamy peanut butter is also a good example of a homogeneous mixture, because every single scoop of creamy peanut butter should be the same, right? Peanut butter is essentially a mixture of ground peanuts and some oil and a little bit of sugar sometimes, but each scoop of this peanut butter should be the same. It's nice and smooth and even because all of the different flavor and oil and peanut particles are all evenly and equally mixed and distributed inside of the peanut butter. So those are our homogeneous mixtures, things that are evenly and equally mixed and distributed. We can also have the opposite of homogeneous mixtures, kind of the flip side of it, which are heterogeneous mixtures. So a heterogeneous mixture is whenever we have very uneven or unequal distribution of our components, of our particles, of our atoms, of our whatever. So in some areas, particles may be super clumped close together. In other areas, they might be way overly spaced out and far apart, but they're not equal and they're not even, right? They're unevenly distributed throughout the mixture. There's more of one type in one area and less of one type in another area. It's not nice and smooth and even like our creamy peanut butter. So like granite is a good example. Granite is a type of rock that people really like to use for like countertops and stuff in their homes. And if you ever look at somebody's granite countertop, you see all these different colors all kind of mixed in around it. The colors come from different minerals that are present in the granite. And the reason why you see all these different ones is that some of the minerals get clumped up with each other. So there might be some more of like darker colored minerals over here and some more lighter colored minerals over here and some more kind of grayish minerals down here and some sort of brownish minerals over here. But all of them combined together give it this kind of rocky, pebbly look. And so because they're all clumped up with other ones and they're not completely evenly mixed out, it is a heterogeneous mixture. It's not equal, it's not even. Some other good examples of kind of like real life examples of heterogeneous mixtures would be something like this salad right here. So every bite of this salad probably is not going to be the exact same as every other bite. On this bite right here, it looks like they're getting a nice raspberry and some, I don't know, pineapple or mango and some spinach, but they're not getting any of the almond slices or the blueberry that are in there. Maybe another bite will have a big piece of strawberry and a whole lot of dressing on it, but they won't have some of this cheese or they won't get a lot of spinach. So each bite of this salad is going to be different because everything in here is not totally 100% evenly distributed, right? The only way to really do that with something like a salad would be to put it all in a blender and blend it for like a couple minutes to get everything equal. Otherwise, we have big pieces of strawberry and big pieces of spinach all mixed around with these little pieces of cheese and little pieces of almond. Maybe you're going to drizzle some dressing on top. And so some of your bites are going to have a lot of dressing on it, and some might be almost completely dry. And that is what makes it a heterogeneous mixture. Not everything is all totally equal. It's not the same everywhere you go. Same thing with, speaking of dressing, if you use like a zesty Italian dressing for salad or for chicken or something like that, you can see that besides the water and oil that kind of make up the base of the dressing, we've also got all these little floating around pieces of some garlic and some peppers in there. And so all these little clumps of garlic and peppers are clumping up together and making this not a 100% totally evenly and equally mixed substance with our Italian dressing. We have some more garlic than pepper down here, but there's some more pepper than garlic over here. And up top, there's a whole lot of mostly just the water and oil and not a lot of either of the pepper and garlic. So not everything is totally equal and even. It is clumped together, it's spread apart, so it is heterogeneous. Same thing with our soil down here. So if you dig underneath the grass in your backyard, you'll find all sorts of different combinations of stuff in the dirt. So if you went in and took like out a scoopful of dirt each time, it's not going to be 100% the same type of dirt that you scoop up. Maybe one handful will have a lot of rocks in it. Maybe one handful will be kind of really sandy and silty. Maybe one handful will have a bunch of sticks and twigs and dead grass, where another handful might be super muddy and squishy. It's all clumped and not equally and evenly distributed, and things aren't totally even with each other. So we have a heterogeneous mixture. So homogeneous, everything is equal, everything is even. We have a fully even distribution of all of our different types of particles that are mixed together. Whereas heterogeneous is not even, it's not equal. It's where we get different amounts of different types of particles in different places. Every piece, every scoop, every drop has the potential to be different from the last one. And that's what makes it a heterogeneous mixture. All right, so if we go back to our flow chart, we have our matter. And up first, we're asking if it can be separated by physical means, which essentially means, are there different types of particles in here? Could we separate out the different types of particles from each other. If we cannot, if there's only one type of particle, actually, no, we're going to start on the other side. If we can, if there are lots of different types of particles that are present that we could maybe separate from each other, then we have a mixture. So again, mixture is lots of different particles all combined, all mixed together. If the composition of our particles is uniform, meaning that it's all totally equal and even, so uniform means like all the same. So if all our particles are all the same distance apart from each other and they're all the same amounts, then we have a homogeneous mixture. Everything is equal and even and the same. If it is not uniform, if there's different clumpings and different amounts of particles in different places, then we have a heterogeneous mixture. So we don't have the same in every part. There's different amounts in different areas. And so that's what makes our mixture heterogeneous. On the flip side, if we don't have different particles that we can split apart from each other, if they're all the same type of particle, then we have a pure substance. So again, pure substance, one type of particle present. If that particle is different atoms that are bonded together, so that's what decomposed by chemical means is saying. It's saying, are there multiple different atoms that are fused together? If there are, then we have a substance called a compound. So again, compound, something like H2O for water, or CO2 for carbon dioxide, or NaCl for salt. It's all different types, it's all different atoms, but the atoms are fused together. They're bonded with each other. On the flip side, if it's only one single type of atom that is there, then it is an element. So elements are when there's just one single type of atom. They're not bonded with anything else. They're not chemically fused with anything. It's just the one type, the one single atom. So that is kind of the very general way that we can take a substance and figure out what type of substance it is. If it's a mixture, what type of mixture is it? Or if it is a pure substance, then what type of chemical, what type of particle is it made out of? All right. So does anybody have any questions about our mixtures, about our pure substances? Anything that you're still a little not sure about that you want me to go back and review a little bit?
No, thank you.
All right, thanks, Breeze. Anybody else, anything, any questions you have, anything you want me to talk about a little bit more, go back and review a little bit? All right. If not, then let me give you a little overview of the homework that goes along with this. So even though there is a midterm going up on Wednesday, that doesn't count as one of your daily assignments. So you still have a Monday, Tuesday, Wednesday, and Thursday assignment to do. I did make sure to make them very short so that you didn't have to worry too much about working on them while also dealing with the midterm. But for our assignment tomorrow, the first part of it is kind of a review of what we just talked about. So it talks about the different types of elements. It talks about the compounds. So again, different elements that are chemically combined with each other. It talks about our mixtures. So we have atoms and compounds and different atoms all combined together in our mixture right here. And then down here, it gives an example of a homogeneous mixture or a heterogeneous mixture. So again, if you look at the homogeneous mixture over here on the left, you can see that even though we have different types of particles, so we have a black element, we have a white element, and then we have a black and white compound, they're all pretty evenly and equally spaced apart, right? So there's about the same number of white and black elements and compounds in here. They're all about the same distance apart. So not exactly, but pretty close. There's not really one area of the mixture where there's a lot more of one type of element versus another type. And then if we compare that to our heterogeneous mixture picture over here, we can see that we have all the black elements are kind of clumped over on the left-hand side. All of the white elements are clumped over on the right-hand side. And all of our compounds are clumped kind of right in the middle, right here. So they're not equal. They're not even. We have kind of different clumpings of our different types of particles. So the fact that they're not totally evenly distributed makes it a heterogeneous mixture. So homogeneous, same, equal. Heterogeneous, different, clumping, not the same. So for the actual homework, it's essentially the same for tonight, Tuesday, as well as your Wednesday homework looks very similar to this. So you're gonna have a series of pictures. I think on Tuesdays, the homework for tonight is just 2 pictures. And so for each picture, for each substance, you have to tell me what type of substance it is. So is it a pure substance? Is it a homogeneous mixture? Or is it a heterogeneous mixture? And then you also have to tell me, are there elements present? Are there compounds present? Or are both elements and compounds present in this substance? So this is what the Google form version looks like. For this assignment, I would recommend you do the Google form version because it just has these different answers that you can click on underneath each substance. The Google Doc version is the same information and the same pictures and the same questions, but you have to go in and physically type in your answers. So again, we have the same 2 substances that we're dealing with for the homework, except instead of clicking on a choice, you just have to fill in on the first line. You'll write down whether it is a pure substance, a homogeneous mixture, or a heterogeneous mixture. And then on the second line, you'll write in if there are elements present, or only compounds present, or if both of them are present. So again, like I said, pretty short. I think this one is 2 questions. And then I think the one that goes up on for Wednesday's assignment is 3 questions. But it's covering the idea of being able to look at the particles of a substance and figure out, is this a pure substance or some type of mixture? And what type of particles are present? Are there elements present only? Are there compounds present only? Or are both of them present in some type of mixture? So that is what your Tuesday and Wednesday assignments will look like. So again, the Wednesday one will go up tomorrow at the same time as the midterm. And it's basically the exact same type of questions. You have some substances, and for each substance, you have to tell me, is it a pure substance or one of the mixtures? And what type of particles are present in the substance? All right. Anybody have any questions about the Tuesday assignment, the Wednesday assignment, the notes that we went over today, or the midterm this week? All righty. Well, if you ever do have questions during the week, please